Hello everyone, this is Yahya again from evyCoding. Hope you're doing good. We have a problem today from LeetCode, the number one problem to sum. Let's read the prompt. So we have a given array of integers called nums and an integer target. Return indices of the two numbers such that they add up to target. And you may assume that each input would have exactly one solution, and you may not use the same elements twice. You can return the answer in any order. Well, the problem consists of having a list of numbers, so we need to find the two numbers. So if you add them together, we will have the target. So let's go to example number 1. We have an input, nums is equal to 2, 7, 11, 15, target is 9. So the output is 0, 1, so because if we add up 2 and 7, we will get 9. This is the explanation. Let's go ahead to example number 2. We have an input, nums is equal to 3, 2, 4, and the target is 6. Of course, the output is 1, 2, because if we add 2 and 4, we will get 6. The same example in 3, so it just repeats. Constraints. We have nums length, so the length of the vector or the array is ranged from 2 to 10 to the power of 4, and nums at I and target also is ranged from minus 10 to the power of 9 until 10 to the power of 9. Only one valid answer exists, so that's it. And also there is a note, can you come up with an algorithm that runs in less than big O of n squared? Well, let's go back to the solutions. We have first one, we have an ordered map and called MP, and the loop starting from ranging from a variable called I, ranging from 0 to the size of this vector. And then the incrementation, of course, we have a variable called soulmates, which is the difference between the target and the number we are working on. We have a condition. If we find soulmate in the map, we should return the number in the second case, which is, of course, the index of this number, and then else we should store the number we are working on and its index in this map. Well, let's check this. First of all, we have 2, so soulmate should be 9 minus 2, which is 7. Well, there is nothing in the map, so it should be, there is no need to return anything, so we're storing 2, the number, and then its index, and of course it's 0. Second of all, we have 7, so soulmate should be 9 minus 7, which is 2. And then that's it. We have 2 in this map, so we're taking the index at first, which is 0, and then the index we're working on now, which is in this case 1, and that's it. This is our solution. That's it. That's it for the first solution. And then we have the second solution, which is we have a loop. So for int I is equal to 0, I is ranging from 0 to the length of this vector, and of course the incrementation. The same variable soulmate, which is the difference between target and the number we are working on. And the second loop, don't mind, we have a 2 loops, so you may be concerned it should be a big O of n squared, but don't worry, this is a solution that works on very good with a good time complexity. We have for int j, we have a variable j ranging from I plus 1 to the last elements of this list. And then we have the incrementation g plus plus. The condition here is if the nums at j is equal to soulmate, we should return I and j. Else, of course, if we exit the both loops, we should return an empty vector. That's it. This is the solution. It's an easy one. So let's just write it down here. Okay. We have the second solution. We have a target. So 2, 7, 11, 15. That's it. And then first one, we have an I and j is here. So we are searching the soulmate. What is equal soulmate? Soulmate is the number. Let's check. Soulmate is equal to target minus the number at I we are working on. In this case, of course, we have the soulmate is equal to 9 minus 2, which is 7. So, and j is starting from I plus 1, which is 7 also. And then we are checking, of course, soulmate is equal to the element at index j, so of course we should return I and j, which is in this case refers to 0 and 1. And that's it. This is the solution. We can check them both. So this is the first one, the first solution. We can submit it and see the time and space complexity. So we have first one, runtime 7 milliseconds and memory 11.49 megabits. And then the second solution, let's see it out. The second one, that's it. We submit it and see the time and space complexity. Well, we have a very, not a bad, but an average time complexity, which is 156 milliseconds, and a memory, a better one, which is 10.68. It's just less than the first one with 1 megabit. So this is, we have two solutions, so you can choose. In my opinion, I prefer the first one. So hope you enjoyed the video and like the explanation, and thank you.